We're at question number 7 of test review 1 for similarity. And we're looking at question number 6. If triangle ABC is similar to triangle FDE, what is the length of DE? Write your answer in a complete sentence. So this is actually solved very much the same as questions number 4 and 5. I'm going to go ahead and write my statement of proportionality. I know that side AB corresponds to FD. BC corresponds to DE. And the first and third position, AC, corresponds to FE. Now I'm going to go ahead and circle the sides that I know. I know AB from our diagram, and I know DF or FD, and I know BC. So let's go ahead and set up our proportion. It's going to be AB over FD. The reason for that is we know the numerator and denominator of that one. And then BC I know. I can put that there. The reason we picked this ratio is because that is the one that has our missing side, DE. So BC over DE. Alright, let's plug in the values. AB is equal to 12, FD is equal to 28, BC is equal to 9, and DE is our unknown. Alright, let's cross multiply. We've got 12 times x, so 12x is equal to 28 times 9. 28 times 9 equals 252. And now we'll divide both sides by 12 to get the x by itself. And 252 divided by 12 equals exactly 21. So to write this as a sentence, all we have to do is just write the length the length of DE, side DE, is 21, and then our unit of measure is millimeters. So there is our answer written as a sentence. Let's go ahead to question number 7. Looks like the same kind of a question. If triangle ABC is similar to triangle XYZ, what is the length of AC? Write your answer in a complete sentence. Alright, let's do the statement of proportionality. From our similarity statement, we know that AB over XY, there's our first ratio. Then we've got BC over YZ. And then we've got AC over XZ. Let's circle what we know. We know AB, we know XY, and we know XZ. This works out good because we're looking for AC, which is part of our second ratio. So we can write our proportion now to solve for AC. We're going to use the ratio that we know the top and bottom of. And then we're going to pick the ratio that has the unknown side that we are looking for. Alright, let's plug in our values. AB is equal to 2. XY is equal to 2.5. AC is our unknown side. And XZ is equal to 3. We can go ahead and cross multiply now. X times 2.5. So 2.5x is equal to 2 times 3, which is 6. Divide both sides by 2.5. So we're going to do 6 divided by 2.5, and we've got 2.4. So x is equal to 2.4. Let's write that as a sentence. The length of, and what we're looking for again, AC of AC is 2.4, and the unit of measure here is feet. There's a couple more examples for you on how to solve for these. Hopefully you're working on these on your own and then checking your answers. Question number 8. What is the length of CF? Okay, now we have a triangle with a parallel line, or a line inside the triangle that's parallel to one of the sides. Now we use triangle proportionality. Remember how we worked this out before? We turn the triangle so the horizontal lines are so the parallel lines are horizontal, and then we said let's put this over this. There's our one ratio, and then we're going to put 3 over 4. There is our other ratio. So we're going to take 40 inches, and that's going to go over our unknown side, and that's going to be equal to 32 inches over 24. This is what triangle proportionality tells us. All right, let's cross multiply. X times 32 is 32x. 40 times 24 is equal to 960. And now we're going to divide both sides by 32. Divided by 32 equals exactly 30. So x equals 30. So our final answer is CF is equal to 30. And this unit, this double apostrophe, or this quotes here, that actually stands for inches. So you can either write inches, or you could just do the actual quotes there. One of the questions that might come up is, how come in this answer I didn't put a line over the top of it? In the previous answer I did. When you're calling it as a side, I'm saying the length of side AC, then you're going to have a line over the top because you're talking about a line segment. But when you just write the equal sign, now you're saying the length of CF is equal to 30 inches. When you say the length of a side, you don't have to put the line on top. You can just call out the two endpoints of that particular line segment. All right. Number 9. If RV is 20, so in this case now we have to label some side lengths. If RV is 20, now be careful, RV is the entire bottom of this diagram. RV is 20, WV is 6, RS is 15, and we're looking for ST. What we want to verify is that to do triangle proportionality, we need to know the length of RW. And I'm going to write down RW is equal to 20 minus 6, and that's equal to 14. So there is our missing side right there. Now I taught you in class, if you have a hard time setting up the proportion, just remember, turn your paper so these two parallel lines are horizontal. Then you're going to number. When you number, you're going to see this is going to be 1, this is going to be 2, that's the left side, and then go back to the right side, and that's going to be 3, and that's going to be equal to 4. So now let's set up our proportion. 1 over 2 equals 3 over 4. 1 is 14 over number 2, which is 6. And that is equal to 15. There's our value for 3. And then x is our unknown. All right, let's cross multiply. 14 times x is 14x. 6 times 15 is 90. Divide both sides by 14. And now we're going to get a decimal. We've got 90 divided by 14. And that's approximately 6.4. So approximately 6.4. And that means our final answer is ST is approximately 6.4. And our unit of measure is meters. Number 9 is done. Let's take a look at number 10. Okay, number 10, they're asking us to simplify ratios. All right, let's do this. We have a ratio with no units of measure. That means all I have to do is just start to simplify it by finding common divisors. I know these are both even numbers. I'm going to divide the top and bottom by 2. 54 divided by 2 is 27. 18 divided by 2 is 9. Now, they're not both even anymore, but I know 27 and 9. 9 goes into 27. That means I can divide the top and bottom by 9. 27 divided by 9 is 3. 9 divided by 9 is 1. So our final answer, it says to write as a simplified ratio, not a fraction. So there is my final answer, 3 to 1, if I can actually get that to show there. There we go. Here's our first one. Let's take a look at the second one. 10 over 24, no units of measure. I can just simplify. It looks like they're both even. 10 divided by 2 is 5. 24 divided by 2 is 12. 5 is prime. That means I can't go any further. And if I'm going to write this as a simplified ratio, it is 5 to 12. Next one, now we have different units of measure. Let's find our strategy to do that. We have our conversion factors up here. I'm going to make sure that when I get rid of my units of measure, I'm going to put feet on bottom, and I'm going to put meters on top. And it says that 10 feet is equal to 3 meters. Now I can cross off all my units of measure because feet show up on top and bottom, meters show up on top and bottom. Let's multiply across. 8 times 3 is 24. 2 times 10 is 20. Again, don't think you're allowed to cross multiply here. We're not making these two fractions equal. We're multiplying these two fractions together. So we multiply across. Numerator times numerator, denominator times denominator. Looks like these both are divisible by 2. So 24 divided by 2 is 12. 20 divided by 2 is 10. We can divide by 2 again. 12 divided by 2 is 6. 10 divided by 2 is 5. Looks like we're done. Let's write it as a simplified ratio, 6 to 5. Now I'm going to make one change here, class. I'm going to put a circle around these numbers so you don't think I'm squaring the number. We're just dividing it by this number. If you're not listening to the audio, you're going to be completely confused as to what I'm doing. So hopefully you're listening to the audio. Alright, next one. Unlike units of measure, we're going to multiply this by a converting fraction, and we're going to take inches and put them on bottom. Centimeters end up on top. We flip them around, and it says 5 centimeters is equal to 2 inches. Okay, our units of measure will cancel now, and we've got 12 times 5, which is 60, and 72 times 2, which is 144. Okay, those both look like even numbers, so I'm going to go ahead and divide them both by 2. I've got 30 divided by 72, and those are even again. Let's divide by 2. And I've got, move that over a little bit, divide by 2, and that's going to give me 15 over, looks like 36. And it looks like 3 goes into both of these numbers, so I can divide by 3. 15 divided by 3 is 5. 36 divided by 3 is 12. 5 is prime, so we're done. Our final ratio is 5 to 12. And again, I'm going to circle these so we recognize I'm not squaring or cubing things. I'm just dividing them. You have your own notation for doing that. That's fine, class. I just put the little number in there. I write it down so I don't forget what I'm dividing the top and the bottom by. All right, there is question number 10. Let's go to question number 11. Find the value of the variables. All right, now we have a proportion. A fraction equal to another fraction. We can cross multiply here. 12 times x is 12x. 4 is equal to 4 times 30. 12, I'm going to write the whole thing out for you. 4 times 30 is 120. 120 divided by 12 is 10. There is our final answer here. Next one, x times 2 is 2x equals 15 times 30. 15 times 30 is equal to 450. Divide both sides by 2, and x is equal to 225. Next two questions, no big deal, we have a binomial. Just cross multiply again. 8, I'm going to put y plus 3 along with the 8. This is 8 times y plus 3, and that equals to 18 times 3. Now we'll distribute. 8 times y is 8y. Let me write that a little bit neater. 8 times 3 is 24. 18 times 3 is 54. Now we're going to subtract 24 from both sides. I'll make a little note. I know some of you need to see that or use that so you can actually work it out. So now on this side all we have is 8y. 54 minus 24 is 30. And now we're going to divide both sides by 8, and y is going to be equal to 3.75. Again, unless I tell you to round it to one decimal, you can write the exact value. Last one, we're going to multiply 6 times y plus 8, and that's going to be equal to 9 times 4. Let's distribute. 6 times y is 6y. 6 times 8 is 48. 9 times 4 is 36. Now we're going to have an unusual situation here. Looks like we're going to end up with a negative number. That's no big deal. Let's subtract 48 from both sides. You're going to end up with 6y equals negative 12. Now we divide both sides by 6, and you're going to end up with y equals negative 2. There's your examples. Hope you're being successful on these. Last question on this video, question number 12. Using the transformations below, what would be the transformed coordinate of negative 7, 12? Well, let's take a look at our transformations. For this one, we're just going to plug in, take our negative 7, 12, and let's plug it into this transformation. X doesn't change, so it stays negative 7. Y flips the sign, so y becomes negative 12. Take a look at the next one. We're going to start off again every time with x, y. There's our original coordinate. Now we're multiplying the x value by 3. Negative 7 times 3 is negative 21. And we've got 12 times 3, and that is 36. There's our new coordinate. Alright, next one. xy, that's negative 7, 12. Now what happens is the y value moves to the front. So 12, which was our old y value, is now in the beginning of our new coordinate. X ends up at the end and the sign flips. So x was negative 7, now it becomes positive 7. And the last one, we'll start off with negative 7, 12. And now this is actually a translation. We're going to do negative 7 plus 8, that's 1. And 12 minus 4, which is 8, and there's our new coordinate. Now if you're interested in this, you could take a look at these. This is a reflection. This one is a dilation. Whoops, get that color right. This one is a dilation. This one is a reflection. Actually, that's funny, not a reflection. This one's a rotation, actually. A rotation. And the last one is a translation. So here's all the different things we can do as far as transformations. Alright, that's the end of this video.